Science Core Heuristics for Open Science Outcomes and Learning project, or the school project, which is part of the NASA Transform to Open Science mission, or NASA TOPS. I just want to remind everyone about the TOPS Code of Conduct. We want to be good citizens when we're in meetings like this. We want to make sure that we practice empathy and humility. We want to participate in authentic and active ways and exercise consideration and respect for each other. We want to be good listeners, and we also want to provide our points of view so that we can help to, accelerate scientific progress. I do want to let everyone know that this meeting is being recorded. So thanks, Juan or Camilla, who started the recording already. I just double checked and it's already happening. So just to bring us all to be on the same page, I mentioned the NASA TOPS mission, or the Transform to Open Science mission. The vision of this mission is a future where scientific discoveries are enabled by inclusive collaborations. So it's meant to empower scientists and communities to embrace open science practices as a catalyst for change. And the strategic objectives are to accelerate scientific discovery, to broaden participation, and to increase understanding of adoption of open science principles and techniques. So how does the TOPS mission conceive of open science? You can see on the chart here that the term open science encompasses a lot of different things. So it means that the science is accessible. So, what does that really mean? If we think about these principles that are called FAIR, FAIR stands for findable, accessible, interoperable, and reusable. So we're saying that open science is science that someone can find, use, and repeat as needed. Not only does this include data and software, it should also include access to documentation and peer-reviewed articles. Another key leg of open science is that it's inclusive. So we bring everyone to the table. We want to expand participation to groups and create new pathways to science. Finally, open science is science that's reproducible. So that means that we use collaborative tools and open frameworks, and we do it out in the open. We want to increase access to what previously might have been hidden knowledge. So to achieve this, NASA first created something called Open Core. You can find this curriculum at openscience101.org. I know many of the members of our open science team have already completed it, but just in case you haven't, this is an online self-led curriculum where you can work through 5 different modules that are each about 2.5 hours long, ranging from the ethos of open science to how to work with open data, open software, or open tools, and then finally how to share open results. So if you haven't checked out Open Core yet, I really would encourage you to go to openscience101.org and work through these modules. Our project is a follow-on to this first effort, and it's what's called the TOPS Science Core project. So whereas the Open Core initiative focused on general open science education, the TOPS Science Core projects, they focus on domain-specific open science. So rather than just talking about how to practice open science as a whole, we're looking particularly within different scientific domains about, how someone working on water or how someone working on air might be able to incorporate open science principles into their research. So with that, I'll hand the floor over to Camilla Green to tell you a bit more about the school project. Camilla, take it away.
Thanks, Kit. Hi, everyone. It's great to see you all today. So in the school project, we're developing a set of lessons on the topics at the bottom of the screen: water resources, health and air quality, environmental justice, disasters, wildfires, agriculture, climate, and with a theme of population and infrastructure woven through all of them. And these lessons take the form of Jupyter or Quarto notebooks, and they can be found on our website, which hopefully you all have been able to view. And these notebooks are uh, they are viewable as HTML pages, but they've got code on them. And in the uh, 2I2C workspace, which you'll be shown later, the code is executable, so you're able to run the code yourself. If you could take it to the next slide. So each of the modules, we're trying to follow this data science life cycle, which is similar to the open science modules, which Kit just showed you. And so each of the modules includes the steps of generation and collection, processing and storage, management and analysis, visualization and interpretation, and open science and community engagement, but with an eye for how to make these processes as open as possible. So using open science tools, open data, and we're also trying to produce these lessons in English and Spanish so that they're as accessible as possible. We're also trying to follow an agile project development management style where modules are released in sprints. And instead of a waterfall process, the agile project management has continuous integration where we're developing these lessons, sending them out to the open science team and other collaborators for feedback, as we're doing today, and taking this feedback and using it in our development process so that instead of getting a lot of feedback at the end where we may have learned that our modules don't hit the marks that we're shooting for, we're getting this feedback as we go through the process.
Thanks so much, Camilla. So, we've told you a bit of an overview about what NASA is focusing on, and then a little bit specifically about what the school project would be focused on. But what's important about these meetings, I think, is to take time to get to know each other. So I'd ask everyone just for a moment to switch on your cameras, and we're going to go around the room. You can say who you are, where you're from, and what is your favorite thing on your desk. So I'll start off. My name is Kit McManus. I'm living in upstate New York in the Catskill Mountains. I'm the PI on the school project, and my background is as a geographic information systems analyst and developer. I have a lot of things on my desk. I tend to play around with a lot of knickknacks, but I think my favorite thing is probably a music box that I brought back from Brussels, which you can see here. I tend to, at certain points throughout the day, pick up the music box and just take a break for a couple seconds. So with that, I want to hand it over. Camilla, you've been speaking, so speak a little more about yourself, and please, when you're finished, popcorn it over to the next person.
Sure, I'd love to. Hi, everyone. My name is Camilla Green. I'm a research staff assistant at Season. I live in Brooklyn, and my favorite thing on my desk is my AirPods, which I've gotten right now because you need the noise cancellation in the city. It's so noisy. And you might be able to hear the street noise right now. So I'll pass it to Christina.
Hi, everyone. I'm Christina Diodatis. I'm also research staff assistant at Season, and I live in Manhattan. My favorite thing is this cool rock that I found while backpacking in Oregon, and it's super smooth, so it's fun to just play with. And I will pass over to Linda.
Thanks, Christina. My name is Linda Pistolesi. I'm a GIS specialist at Season. I'm part of the TOPS school team. I'm in Rockland County, New York, which is just outside of the city. And my favorite thing on my desk is this little wind-up toucan that I've had since I was a child, and it still works. So that's my favorite thing. And I'll popcorn it over to Juan, my other team member.
Hi, everybody. How are you? My name is Juan Martinez. I'm a senior research assistant at Season. Currently in East Harlem. I was born in Colombia. My favorite thing in my desk right now is this NASA notebook that I bought myself. It's just a leather top. And when I'm done with it, I can just change out the pages. So it's reusable. Nice to meet you. Oh, I will pass it over to Gianna.
Hi, my name is Gianna. I'm currently an undergrad student at Loyola University. I'm majoring in software engineering. I'm also from Chicago. And my favorite thing on my desk is my headphones. I use them every day. And I'll popcorn to Akshay.
Hello. Good afternoon, sir. My name is Akshay. I'm from DePaul University. I'm not from NLU, so that's a little different for me. Again, like from Max, and I'm not from here. I'm from the UK, but I'm in Chicago right now, doing my master's in AI, and possibly in future I'll get my PhD in the same domain I want to teach. So, and my favorite thing on my desk is this book that one lady gifted me. It's about UI design. So I'm getting into learning about more of UI. Oh, sorry, if you can't see. So it's about the UI design. So I'm trying to make a better website. So that's why I just want to learn about this thing. Yeah. I'll pass it over to who's on my screen. I'll give it to Alex. I can see him here.
Hi, Akshay. A long time. Hi, everyone. I'm Alex, and I'm full stack developer, software engineer. I'm from Chicago, and right now I'm at the office. And at the office, my favorite things on the desk is I hope my manager won't hear me. But at home, I like to be cooked. All right, and I will pass to Dr. Antonio.
How's everybody doing today? My name is Antonio Tovar. I'm actually a faculty member at the National Laws University in the computer science department. I think I know most of the Chicago, I want to call them interns or you know, they're actually providing us with a lot of help. So I tend to oversee all of them here, just to make sure we are contributing. If there's any problems, to step in and help out as much as I can. I actually teach Open Science 101, right? I'm part of the faculty who teaches, and that's how we met. That's how we met everyone here. In fact, that's how we met Juan and Kit, right? As well, as part of that. My favorite thing on my desk, I spend a lot of time at home in my office. I have a Buddhist prayer bead. I don't know if you guys can see that. Right. A lot of stuff happening. Sometimes you need to kind of, you know, do a little prayer to make sure it works, right? And then it works. So I'm happy to be here. And I'm going to pass it to David Fonseca. Go ahead, David.
Right, yes. So hi, my name is David. I'm an undergraduate student at NLU. I'm majoring in computer science. I'm based in Chicago right now, but I'm actually from Colombia. Um, so it's been a pleasure working with you guys. I'm not at home right now, but what I have on my desk right now is my coffee. So I would say probably I need it. I need coffee sometimes, you know, like doing homework assignments and so on. And yeah, that's about me. I'll pass it over to Albert. Thank you.
Okay, thank you, David. I'm Albert. I'm from Colombia too. I'm quite surprised. I have a lot of Colombians, but I live in Brazil. I'm a research assistant in the National Institute for Space Research in Brazil. and I really like open science. My favorite object is this ruler in centimeters. Okay, it's a little bit blurred. Okay, it's something I got during my master's in Germany. It's kind of a joke because it's a ruler, but I got it in a store called the Bauhaus. That is a hardware store. The Bauhaus is a famous artist, I don't know how to call it, enterprise in Germany. So it's kind of a joke. And I use it for taking measures, just centimeters. I'm sorry for my American friends, centimeters in one side and centimeters in the other side too. So, well, thank you for having me here. I'm going to pass to, I don't know who.
The next person on my screen is Juan de Dios.
Okay, I'm passing to Juan. Thank you.
Okay, Juan, if you can't talk at this moment, the next person on my screen is Anis.
Hello, everyone. I apologize. I'm having some camera issues, but I am glad to be here. My name is Anise Williams. I am the Environmental Management Systems Coordinator at the City of West Palm Beach in the Public Utilities Department. And I guess like a couple people already mentioned, headphones is my favorite thing on my desk. And I'm glad to be here and looking forward to hearing everybody else's favorite thing.
Thank you, Anis. The next person is Ying Zhang.
Okay, hi everyone. My name is Ying, and I'm currently a research assistant from the University of Illinois. I'm focusing on sustainable transportation, and I'm really glad to be here. I think my favorite thing on the desk is currently the candle. It's really relaxing. Thank you.
Thank you. Juan, I also see your note in the chat that you're having some technical problems. No worries. If they come through, please turn your camera on and we'll give you a chance to introduce yourself. The next person on my list is Hugh Tran.
Thanks, Kit. Nice meeting everyone. My name is Hugh Tran, currently a junior programmer at Season, along with other folks here. My background in CS and data science. My favorite things from it is the tic-tac-toe interactive things that remind me of human can beat an AI. Thanks.
Thanks, Hugh. Next person on the list is Daniel Alvarez. Hi, Daniel. We see you, but you're muted.
Oh, sorry. Hello, everyone. My name is Daniel Alvarez. I'm a undergraduate from National Louis University, and I am majoring in computer science. I guess I would say that my favorite thing on my desk right now, I'm not really in my normal setup right now. I'm in some other place, but I guess I would say this water bottle, I guess. Just because you need your water, I guess. So that's my favorite thing, I guess. But thank you. Nice to meet all of you.
Yes, thank you. I have one of those on my desk too. So George, you jumped the line by turning your camera on, but it's good. I'll hand it to George Verghese.
Hi everyone, hope you're doing well. My name is George Verghese, from India, from a state called Kerala. I have a background in urban design and urban planning, but keen affinity and interest towards programming and geospatial applications. At Season, I'm currently a programmer. My core responsibilities involve supporting NASA's Data GIS program, which is one of their enterprise platforms, which is on the cloud. I am unfortunately the type of person who doesn't like having anything at his desk. So if you come to Season, I'll probably be one of the few folks who will have nothing at their desk, like it's empty. But I did get a new mouse recently, so I do enjoy this. So yeah, thank you. And great to see everyone. And I'll pop
Thanks,
it
John.
over to Emily. Oh, I saw that text. If Greg's there, I'll pop it over to Greg then. Thank you.
Hey, good afternoon, everybody. Greg Yetman, Associate Director for Geospatial Applications at Season. I'm involved with the TOPS program as well. My background is in geography and development, and by development, I mean code development, and a few other things. And I'm working from home today, and I'm looking at my desk, and it's all either like bills or stationery. So I'm going to go with, oh, actually, I know what I'll go with. I'll be honest and go with my iPad that I use all the time for media. I don't use it for work. I only use it for media consumption. So there we go. Favorite thing is iPad. And who should I go with? Who hasn't gone? Kit, do you have a good track on who should be next?
Yeah, I do.
I think,
So Jordy, I know you haven't gone.
Yes. Hello, good afternoon, everyone. Yeah, my name is Jordi Rodriguez. I'm a student at National Louis University. I would say that right now, I'm not at home, but my favorite thing would have to be my new Mac Mini that I just picked up this week. And I'm pretty happy with it. Thank you.
Thanks, Jordy. Then the next person on my list is Ahanaf Aziz.
Hey everyone, I am Ahanaf Aziz and I'm from Bangladesh and I'm studying an undergraduate student at Andhra University. And as a computer science engineering student, I always fascinated about computer science. So my favorite thing on my desk is this book, Computer System Architecture book. I want to learn core system of the computers and I want to build something that's gonna revolutionary and something which is gonna fascinate into the whole human. Thank you.
Thank you. So I think the only folks who haven't gone have indicated that they can't talk. So hello, Emily, also as well. I saw your note in the chat that you can't talk at the moment, but it's nice to have you here. You know, the introductions, they always take a little bit of time, and when you have an hour meeting, maybe they take 10 minutes or 15 minutes, but they're just so important, especially the spirit of what we're doing here with open science. We really want to get to know each other. So I think it's always important to pause and take that time to introduce each other. So with that, I'll hand it over to Christina to talk a bit more about some of the school meeting artifacts.
Yeah, thank you, Kit. So these are some of our open science tools that we use to make sure that we're keeping record of the events that we're holding and all the materials associated with that. So this first one is Zenodo, which is a website where we have our TOPS T school group, and then for every video that we record, every meeting that we attend, and events that we present at, we'll create a record of that, and we'll upload all of the associated documents that accompany that for people to view, and then it can also be downloaded. And at this link, we'll send out a document later. You can access everything in the past that we've put together. We also have everything uploaded onto our YouTube channel, which you can also access at this link. Most of these are linked on our Zenodo if they're not already uploaded onto our Zenodo, or both. But here we upload meetings that we have with NLU students or events that we speak at and show our work. So this is also a great resource that we have so that we can access our past materials. And then our last sort of open science tool that we're using is Zotero, which is a management for literature software. We're able to create folders for all of our different module topics. So you can see on the right side, we have health and air quality, disasters and wildfires, and water. And these are accessible to everyone. And you have all the information on the papers that we're using. Abstracts are available too, ways to access them. And we've been having NLU students also upload things for our different modules. We're also going to talk a little bit about our module 0. So at this link, which you can visit later, we have our prerequisites and glossary that we've created. So this was community generated with NLU students, Drupal and America, and they're working on expanding our water module. But this is a lesson that has general information on the prerequisites that are needed to help with this lesson and the glossary of terms that are found throughout the module. So you'll see layouts of the programs that are used. So there's a RStudio layout, there's overviews of the accounts that we have folks create for our lessons, and then there's a glossary of terms and references that are useful for individuals who are walking through this. So it's a really useful overview before diving into any of the lessons, and really urge folks to look at it, and would love to see some feedback on it. I can also place the link in the chat here for people to access.
Yeah, I noticed that Linda has her hand up. Linda?
Sorry, I was actually just gonna say, can you put the link in the chat so folks can see it?
Yes, yeah, I just put it in there, and if anyone has any problems accessing it,
Yeah.
let me know. But
If I could just add that the current link that you see there was written initially for the water module, but we're working with National Louis University students to expand it beyond the water module and include all of the modules. So expanding that glossary, glossary terms to include to all modules. Some students that are present are also incorporating that glossary into Sphinx formats so that it can be more interactive with the modules as well.
Cool. Thank you, Juan. So why not let's take just a couple of minutes for you to review that link to Water Module 1. So we'll just take 2 or 3 minutes here, and we put together a form at slido.com, which maybe Christina, do you want to say a bit more about that?
yeah, for sure. You can access it via this QR code if you have your phones. You can also access it by typing in slido.com, and then there should be something prompt at the top for the code, which is here. And then I have active our open text poll for feedback on module 0. So once folks have opened the link and gone through it, you should just be able to type in and then see results as they're coming in that are being sent. It should be fully anonymous, so those who don't want their feedback to be public, it will be anonymous. So
Sure, thank you. So I'm just going to throw that link in the chat to the Slido. All right. So it's slido.com. Then the number is 7872 132. So we'd like everyone just to take a minute or two, look at the example from the top school water module 0 glossary, and then let us know what types of things might you want to see in a module 0 or the other modules.
Yeah, so just to give you some context, the lesson 0 is for kind of a place where people can first go to understand what their prerequisites are for these modules. So sometimes if you're using Python scripts or if you're using NASA data, sometimes those things will require usernames or will require for you to create an account. And so this is kind of a place where we try to add that information, as well as a glossary of terms that you will see throughout the modules that, not everybody's familiar with, spatial data or packages. So we try to make sure that those definitions are there as well.
I just wanted to add, I know it's gonna take some time to go through the whole thing, right? I've been part of it, so I know exactly what it has and everything. But if you guys, after the meeting finishes, you guys wanna review it, get your thoughts together, I'm sure this Slido, comment tool is gonna be available for you guys to come back and add some additional comments. It's important, guys.
Yeah, absolutely. Thank you for that, Dr. Tovar. So we'll give just one more moment now, but as Dr. Tovar said, we will leave these links open.
Yeah, and Christina will follow up with a document that will have all the links, including this one.
Okay. So with that, I'd like to hand it over to Juan Martinez to talk a little bit more about the technical aspects of the work.
Thank you so much, Kit. So, we, as my colleague mentioned before, we're trying to do this project through an agile development style, as well as to try to incorporate open science principles throughout. So we try to use some of these open source tools that allow us to share with you any updates that we're doing, as well as allow this group to provide feedback and kind of also contribute in their own capacity. So some of the things that we're using to be able to do that is primarily GitHub or the GitHub repos. These right now allow us to store all of our content and share all of the backend files, as well as provide rendered HTML pages that are easily readable and accessible. We're also working with some partners at 2i2c to create these kind of Jupyter hubs and Jupyter books to be able to make these modules interactive. I know that maybe CDAC at NASA is also trying to create some of these standalone notebooks. So hopefully we'll be able to incorporate these curriculum with that environment. So the link below is our GitHub IO page, which is essentially a rendered presentable image of our website. And so you'll have a lot of information about how to get involved, some events that we've been doing, as well as access to the modules. As they get developed, we start putting those links up in this webpage. Next slide, please. So as I mentioned, there is another organization that is part of the TOPS project called 2i2c. And with them, we've been able to stand up a lot of these modules in an environment that, once we share with users, they can go and have a very powerful online environment that allows them to use the data, allows them to run the scripts and change any attributes in the scripts. So it's a much more dynamic way to interact with these lessons. And what you're seeing here is an example of what the environment looks like. It is online. So all you have to do is go to this, URL, and it'll spin up your personal virtual environment with preloaded lessons in them, as well as some of the data that is available either in the cloud or we share it in these folders so that it's easily accessible for everybody. Next slide. So currently we're finalizing our module 2, which is focused on air quality. We're still kind of putting together the lessons. We've got a lot of help from students from NLU that have contributed, a lot of research to us. They've contributed text and as well as some feedback for this particular module. So pretty soon we'll have some sort of like a beta release of the air quality module. This module would be primarily in Python, in the Python language. And it's again going to be using data, open source data, either NASA data, or we also use some GATM data that is publicly available. And so the idea is that, once this module is out, that perhaps some of you can test it out and give us some feedback, and so that you can interact with it as well. Next slide.
Thanks. So we have another slide out here about, what folks would like to see in Module 2. So I'll give just a minute now if you want to put in an answer while it's fresh on your mind. But we'll keep it brief, and, as we said, we'll make these available after the meeting for continued feedback.
Kit, can you put the link to Module 2 in the, there we go. Thanks, Juan.
Okay, so in the interest of time, we'll continue. So, that's kind of the backbone and the framework of what we've been doing. This slide is about some of the outreach that we've done in the past year. So we've held an in-person workshop in the fall of 2023 as part of this NSF iGuide effort. NSF iGuide is, another platform devoted to cloud computing, and it does contain a Jupyter Hub instance similar to what we see in 2I2C. There's a great group of people from the University of Illinois, Urbana-Champaign, and University of Minnesota, and many other groups, including Columbia University, that are involved in this iGuide effort. They're creating something that's called a convergence curriculum for geospatial science, which is, very, very interesting. We've also, in the spring of 2024, we held a workshop at the American Association of Geographers annual meeting, where we met with subject matter experts on health and air quality and environmental justice. And we brainstormed some of the fodder that helped us to kick off the health and air quality module. And then similarly, at the ESIP summer meeting in July, we held a subject matter expert workshop where we kicked off a forthcoming module on disasters and wildfires, which I'll say more about in a moment. And then Juan, do you want to say something about the work at AmeriGeo and at NDS, Tim?
Yeah, sure. So for AmeriGeo, this is a kind of a consortium of geospatial agencies in Central and South America. And we did a virtual training with them using the water module. We translated one of the lessons and kind of tailored it to that region. And we again use the same files that I showed you. We used the 2I2C virtual environment, and we opened it up to whoever was present so that they could follow along in the lesson as we kind of showed them how to use these data sets, how to load them, how to use them. And it was all in Spanish. It was focused in that region, and we had about 100 people there. We didn't really have any issues with the technology, which is great. The other conference that we did was recently the NDI STEM, which is a National Diversity and STEM conference. We were invited there to talk about open science, and we talked about this project. I mentioned, of course, the work with the NLU students, and it was for a panel that was focused on open science and AI, and that the NASA Science Office led.
Thank you. So, we've been busy getting out in the field to get more input on these approaches and to make people aware of all the great work that you guys on our open science. As I mentioned, that I should have said ESIP stands for the Earth Science Information Partners. It's it's a loose relationship between U.S. federal government agencies where they talk about things like standards and data. At the ESIP summer meeting in Asheville, we kicked off a subject matter expert workshop for our forthcoming disasters module. And, some of the take-home messages we got there was that we need to incorporate this disaster life cycle into our teaching. So the disaster life cycle looks kind of similar to the data science life cycle or the open science life cycle. We see a pattern starting to emerge here. Data science life cycle often starts with trying to mitigate and prepare for a disaster. If a disaster occurs, then there's a section where we're responding to it, and then maybe a long or a short recovery after that. And then the cycle continues back into mitigating future disasters and preparing, and then responding and recovering from ones that have occurred. I have a photo here on the bottom left that was collected after flash flooding in Hawaii and Maui. So one idea that we got from the group was to do a lesson about damage assessments, potentially using drone data like this image here, as well as other ideas too. Of course, we want to open it up to even more ideas from all of you about, what would we like to see in a module devoted to disasters and wildfires. But as we're getting close to the end of the hour, I'm going to skip over this for now. And again, we'll provide information to provide feedback to after the meeting. So I did want to just recognize the great work that many of you and, Dr. Tovar at National Louis University have been doing for this project. As Dr. Tovar mentioned, he's one of the fellow TOPS T awardees and has been focused on teaching summer schools where they're teaching the Open Science 101 with Dr. Robin Moncrief and others at NLU. I know many of you have taken those classes even. I want to recognize all of you capstone students here who have volunteered for the Open Science team, and you're really helping us to revolutionize things. You know, Akshay, I don't have a slide in here on Sphinx because I don't think we're quite ready for it yet, but I want to recognize you and call you out for all of the major contributions that you've been making to this project and helping to develop a framework using Sphinx. We couldn't be happier and more grateful to you. And I think for NASA, it's really showing them why open science is important and how getting more people at the table can lead to innovation. So we want to be really thankful and acknowledging the work that you all are doing. Part of the way we do that is by putting entries up on Zenodo and YouTube, where then they can be added to people's resumes and hopefully help you in your careers as well. Juan, did you want to talk through how we're handling the task management in GitHub for our interactions with NLU?
Yeah, so part of the challenge of doing this open science project is that you have to work alongside different groups. As you can see today, we have several people from a wide range of locations. There's different people with different experiences, different backgrounds that all want to participate. So one of the challenges is trying to figure out how we can have contributions from all this wide range of people that are here. So one way in which we've tried to do that with the NLU students is by using a GitHub project, which is essentially kind of like a card task Kanban layout, and so this allows us to kind of assign and create individual tasks that are assigned to each person, and it allows us to have comments and relate it back and tie it back to a repository or a specific file within a repository. And then these updates and once these tasks are completed, they ultimately become pull requests from GitHub that change our files and change and essentially affect what people see when they visit these websites. If I can maybe share screens, I can show you what that looks like, so that people have a better understanding.
I can
everybody's seeing a screen. So this is what our task project looks like. We've split it into different sections, in review, completed, in progress. And so depending on where the task is, we'll place it in one of these buckets. What's great is that, you can create tasks that link back to each repository. You could see, for example, this task here, you can add a lot of information about what repository or what links you're talking about, and also reply with comments, and create some sort of start date and end dates. Eventually, these tasks, as I mentioned, tie back to an issue within a repo, so that other people that are connected to that repository can receive emails and can receive notifications when these are assigned to them. So usually what we do every other Friday is there's a team item view. And so you'll see here that we have everybody's name attached to with our respective task. But what I'll usually do is that, I'll look at each person and review each of these tasks. This task, we actually recently talked about it, Alex, and I believe you completed this task. So you can see over here that it's a closed task. So, in this meeting, I would tell Alex, you complete this task, you want to pick up one, and we would have a discussion maybe about Sphinx, in which that's where we're moving towards. So we just go down this list to make sure that people give updates. The tasks sometimes are about reviewing code, but other people are doing literature reviews. Some people here are focused on developing the Sphinx websites. Other people are doing draft narratives. So there's a wide range of tasks that you can do, that we try to fit you in with your interests. We try to fit you in with your skills. But ultimately, we would like you to learn something about contributing. And so the way that that looks for us is creating these pull requests from the work that you've done, so that it becomes, whatever it is that you're contributing, becomes live and becomes part of this project. So these are just kind of some ways in which we're trying to manage the tasks that come from everybody who have different times, different degrees of commitments. So it's just a good way to manage a project that is so fluid when it comes to open science. It hits on a lot of themes for open science, where this project is open to the public. They can see what's going on. They can see where other people are at, all the comments. So we try to use this for many reasons as well.
Cool. Thank you, Juan. So, another example we have of a community contribution came to us somewhat unexpectedly from a program manager named Jacob Orser, who's at the University of Maryland, and he's part of the NASA Acres project. So we've mentioned so far our existing water module, the health and air quality module, which will be out soon, the wildfires and disasters module, which is next in line. We'll also be having a climate and agricultural module. So the NASA Acres program is focused on agriculture. And Jacob at UMD, he was very nice to put together a proposal for a lesson for us for the climate and agriculture module. So he basically put together a couple of pages of text on some background on the narrative, on why doing a lesson like this might matter, some information on what the story should be, including sources and data sets, as well as even an overview of what the lesson might look like. So at the end of the day, we're building a framework here for community contributions, as well as producing core lessons ourselves, and proposed lessons from our colleagues at NASA, or in professional settings around the world, or really the general public, are something that we would consider to develop with our core team of developers. But also we're paving the way for people to be able to propose and create their own lessons as well. So these are just a couple examples of successful interactions we've had with folks at NLU, and now with folks at University of Maryland in the NASA Acres program. So we've thrown a lot of information at you today. It's always important to stop and think and take some time to reflect. So I want to create some space right now for us to think about a couple of questions. The first is, did I learn something new today? Another thing we might reflect on is there anything from what was presented that I'm feeling uncertain about? Another question might be, do I know someone who would really like to participate in this project? How can we help to spread the word? Or also just an open question about any other reflections that you might have. But I just want to open the room for these reflections. So please feel free to come off mute. Again, did you learn something new today? Is there anything you're uncertain about? where do you think this could go next, or who might be involved, or any other type of reflection you might have about what we've been speaking about. So please come off mute if you'd like, or raise your hand. And Akshay, go ahead.
Yeah, so I mean, it was pretty good to see retrospective and view of like what we have been doing so far. So it's pretty nice. But one thing I just want to understand is like, what is like, as we decided, like, oh, we go with this with that agile methodology. So like, there's everything is in sprints. So like, is there like a time frame for release of every module? Like, okay, like what's a module? Like module 1 should release in 3 months, or like the air module would be something that will happen after that, or like how is it going to be? Like, is there like, do we do everything in parallel, or like is it sequential?
Yeah. So initially we had viewed it as a sequential thing, but kind of organically it's become more of a parallel effort where we're working on content across multiple modules at once. So I think for our team, the first 8 months or so, we were developing this proof of concept in the water module. And then we found with the health and air quality, we were able to accelerate the development from what we learned in the water module. So it's taken, 4 to 6 months to get what took 8 to 10 months in the water module. And then we're hoping for wildfires and disasters and climate and agriculture that we'll finish them up over the next 8 months or so. So it's in parallel, but each module's timeline has been getting shorter as our team has been getting better at doing these types of things. That was a great question.
Yeah, thank you.
Thank you. Any other reflections that anyone would like to offer? Did you learn anything new today? Is there anything that you're feeling uncertain about?
I'm sorry, I have one more. I couldn't keep it to myself. I'm so sorry. Like that's something bugging me. So what I was saying was, and it's not a reflection, but like, what I feel is like, the word should go out that like, okay, there's a community who's kind of actively writing these lessons and like, publishing this content out there. So some people might be interested in it, some people might not. So that's a different thing. So when I was telling a couple of people in my school, like, hey, I was doing this thing, and out of a sudden, I'm sorry, like this is an anecdote from like a couple of weeks. So one lady was like, she was interested into GIS, and when I was sharing the links with her, she got fascinated with like what is possible, and she wants to contribute, but she has no idea how to get started. So I think, we should like put out a word that, okay, there's something that is happening. And if anyone wants to contribute, like, feel free to do that. So like, instead of like keeping it to ourselves, like, just make it more public.
Yeah, absolutely. I couldn't agree more. And I think we're on the precipice right now of taking that next step and doing just that. But I think we're thinking much the same.
Yeah, I have another meeting going on right now, so I need to jump off in a bit. But you gotta remember, actually, almost every quarter, I bring new students in, right? And there is an onboarding process that happens, right? So the introduction to the project, Juan is been nice enough to do this work for us. So if you encounter somebody that's interested, invite him to this introductory meetings, right? Then we can go and then cover more, because there's so many different ways that anybody can contribute to this, right? If so, you say, hey, we can use your help. That's what I say all the time. Of course we can use your help, right? Come to our meetings. Let's talk about this, right? And then hopefully after that introductory meeting, they're saying, you know what, this is very interesting. I want to join, right? And I think we haven't had anybody that says, I don't want to join, right? Because there's so much stuff to do, right? And really what I'm speaking for Keith, obviously, a little bit is we want to put a sort of a standard of how research is published. I think that's what we're going after, right? And create that community that will feel like they're contributing to something and they're happy to contribute. I think that's the whole idea behind this.
Yeah, absolutely. Thank you for that very valuable comment, and also for the reminder that we're hitting the top of the hour. So I know many people will have to drop. So I'll just leave you with this final slide about where to find us and how to stay involved. We are planning to have a workshop at the Earth Science Information Partners winter meeting. This is a fully virtual meeting. So again, we'll share some of these documents with links to these things after the meeting as well. If you want to reach out online, you can go to either our email, topschool@season.columbia.edu, or on the website of our landing page on the website, there's a Get Involved section where you can learn more about how to get involved. We're also in the process of planning for a subject matter expert panel at the American Association of Geographers meeting in March of 2025. That will be located in Detroit, Michigan. And there is also an online option for joining in on those meetings. There are some fees associated with some of these meetings, but it's something where if you have an interest and you don't have the money, reach out to us and we'll see if there's anything that we could do to help. Other than that, I just want to thank everyone again for attending today. As we said, we're going to follow up with more information and requests for feedback. And it's really been a great, working with many of you over these past several months. And I think what we're doing here, it's really a monumental proof that open science, one, it works, and two, it accelerates what you can do. So it couldn't be more thankful to all you on our open science team. Thanks again. I don't want to keep you too far over the hour. So if anything comes up, you have feedback or questions, please go ahead and send us an email. Otherwise, we'll be in touch, and have a great weekend.
Thanks. Have a good weekend, everyone, as well.
Thank you. Have a good weekend.
Bye, everyone.